Okay, so I have my geometric shape objects. I have a cone, I have a torus, I don't have a cube. Okay, I'm going to add a cube later, but let's just start with the torus. Okay, so what I'm going to do now in my project, I'm going to create a new JS file. I call it diamond ring. Okay, and then I call it class diamond ring, and I will build my constructor, and I need to draw it later on. Okay, so I have my draw function, and for my draw function, I'm going to copy it from whatever draw function you have before. Okay, but for now, I just need to copy the exact same argument. So let me just copy it from my previous object. So I'm going to copy the header of my draw. Okay, so why do I use this draw function? Because the rest of my program has been set up to use one vertex attribute, one color attribute, and one uniform matrix. Okay, let me show you. So this is my vertex shader. This is my vertex shader. So I have my vertex attribute, my position attribute, and then I have my color, my model coordinate frame, and I have to match everything together. So in my diamond ring, so the first step is I need to create my ring object. So what do you call this object? What is the proper name for that object?
The band.
The band, okay. So the band is just a new torus, okay? And in my new torus, my torus has several arguments, and the major radius. So the major radius in my code, the major radius will be the radius from the origin to the center of my torus. So with this number, that means the major radius is inner radius, a number between the two, right? 0.875. Okay?
Yes.
So 0.875.
You mean too many points.
Thank you. And my minor radius is the radius of the band, which is
0.25.
is it 0.25 or 0.125?
It'd be 125.
0.125, right? Okay. And I'm going to do a number of subdivision. Let's say 30 subdivision along the big circle, and then 10 subdivision along the smaller ring. Okay. I have one object, the band. Okay. And then the second object that I have to create is the crown. So the crown, and then what is the radius? The outer radius is 0.1. The inner radius is 0.2. So the major radius is 0.15. Okay? And the minor radius for my code will be
0.05.
0.05. Okay, let's say I'm going to be using the same subdivision. Okay? But also in addition, I need to prepare two matrices. Okay? And then let's call this one this band transform mat for create. Okay? And then this crown transform equals mat for create. Okay? So how do I render? So one of the parameter is the coordinate frame of the entire band, because let's say you're going to throw the diamond ring and then you want to do some animation with that, and so you need to use the incoming coordinate frame. Okay? So the first thing I need to do, I have in my draw function, I have to do some multiplication of matrix, but when I do my matrix multiplication, I do have to keep the result. Okay, so then in addition to the two mat4 objects, then I'm going to create another temp. Okay, question so far? So then the main part here is just to render my band, to draw my band. Okay. Well, what are the arguments that I have to pass to my band? I need to pass the color attribute. I need to pass the vertex attribute. I need to pass the color attribute. I need to pass the model uniform, the incoming model uniform. Okay. But I have to multiply my band transform with the incoming coordinate frame. Okay, so then the step would be something like this. Mat for multiply. Okay, I want to keep the result in TMP. Okay, but I want to multiply the incoming coordinate frame with the band transform. Then I'm going to use the temp as the product of the two. I know we are running out of time, so I think I have to stop here. Okay, and then I will continue next week. So let me run the program for now. Okay, and if I go back to my diamondring.js, and what we have in here is just two objects, band and a crown. And in my draw function, currently I'm drawing only the band. Okay, so what is the band? A band. The band is just a torus, right? So we set the dimension and subdivision and other parameters. So let me run my local page, and I need to go back to my index HTML. Run. So you just looking at just a torus, right? So it's not a complete object yet. But the output is different from what you have seen before. Now I'm splitting the window into two sections, left and right. Okay, and what I'm doing on my left section is the perspective view of the object, and then on the right side, I'm looking at the top view of the object. Okay, so remember the coloring scheme that I use for my axis. Red is what axis? X. Green is Y, and Z is pointing towards you. Okay, so this is the top view. The top view. Okay, the top view, and then this is the perspective view. How do we do something like this? How do you split? How do you split? So let me show you the code. Let me go back to my JavaScript code. Okay, and in order to do something like that, I need to set up two virtual cameras. One is to look at the perspective view, and the second camera is for the top view. Okay, and line. Let me go back to presentation mode. So in my main function, line 58. This is where I create the perspective camera using the look at function. Okay, so the look at function takes three arguments. The first argument is the location of your eye. Okay, and then the second argument is the point of interest. Okay, which point you are looking at into the world. And then the third argument is which way is up. Which way is up. Okay, so I place my eye at 2, 2, 2. Okay. And then I'm looking at the origin, and then the z-axis is the up direction for my perspective camera. Okay, and then in addition to the first view matrix, I have the second one. I call it top view matrix, and the top view matrix is set up so then it is looking at from the z-axis, right? So the location of the camera is at 0, 0, 2 at the z-axis because I want to look at the top. Okay, and then the second camera is looking at the origin, 0, 0, 0. But now here, I want to make the y-axis the up direction for my second camera. Okay, so that's why if you look at the output here, the y is now the up direction. Okay? For the first perspective camera, the z is the up direction. Okay? Question about setting up the two view matrix for the two virtual cameras. Okay, so now how do we use the two matrices here? So let me show you the render function. Okay, if I show you my render function now, I split the logic of my render function into three smaller functions. The first one is draw 3D. Okay, and then there's a second function, I call it draw top view, and then draw front view. Okay, so the front view will be on the second half, the right half of the screen, and then the perspective view would be the let me correct what I just said. Ignore front view for now. I don't have any code in my front view. Okay, so the draw 3D will be rendering the perspective view on the left-hand side of the screen, and then the top view will be rendering the object on the right-hand side of the screen. Okay, so what do I do inside my draw 3D? In my draw 3D, I need to set up the matrix. So, but remember, because we are using two separate virtual cameras, then I need to initialize my uniform matrix with its respective camera matrix, right? When I start my draw 3D function, I need to initialize the view uniform variable in my shader with my view matrix. But for the second view, for the top view, I want to initialize with the top view matrix. Okay? And then you call draw scene like you did before. So the only difference is setting up the virtual camera, and you call the draw scene function in both places. Question about the structure of the draw 3D and draw top view. Okay. So now let me look at the draw scene. So the draw scene is just the main code is in here, okay? And I'm applying the rotation matrix to my cone. Well, I didn't change the name because the other object that I rendered before rendering the diamond ring is a cone. So I'm using the same matrix, but you can just simply change this to diamond or diamond ring coordinate frame. Okay, but the idea here is the old code that I had before. I want to apply rotation to my object, and then in order to apply rotation, I need to come up with a new matrix, and then the result is TMP, and then TMP. So this is the matrix multiplication here on the right side as a comment, right? So I want to multiply the cone rotation with the cone coordinate frame to get the product, and then I'm using the product to render my object. Okay? So, so now let me go back to my main, and my main, look at line 72. My line 72 is when I create the diamond ring object as part of my main function, right? This is inside my main function. So line 72 is when I create my diamond ring object, okay? So the diamond ring is set up and then it's rendered correctly. So now if you don't have any question on the structure of the main function, now let me move to the other JavaScript file. Okay, so let's take a look at the other file, the JavaScript file, the diamond ring. So remember, what we want to do is to place a band as a torus, and then I'm going to place another torus at the crown of my band, and then I'm going to place a cube as my diamond. Okay, so But the way when I create my torus, the axis of symmetry is the z-axis. Okay? So what I want to do is I want to put the ring upright. So when I want to put the ring upright, that means I need to do what transformation? Rotation on what axis by how many degrees? Z-axis by 90 degrees? I want to make it upright, so I have to rotate around either X or Y, right? I want to rotate either on the x-axis or the y-axis. Okay? Question? Red, green, blue, red, green, blue, X, Y, Z. Okay, X, Y, Z. So the torus is built around the z-axis, right? Okay, this is the z-axis, the blue axis is the z-axis. So I want to put it upright, so I want to either rotate around the x or around the y. Okay? So let's say I want to rotate around the x-axis. So how do I use the mat4 class? So the mat4 class, there's a function to create a rotation. Okay, so from x rotation, that will be a function. Let me look at my printout of the glMatrix function calls here. So I can use mat4. I can use mat4 rotate x. I can use mat4 rotate x. Mat4 rotate x, and then I want to apply 90 degrees rotation. So, and the output will go to band transform. Okay. So the rotate x takes 3 arguments. The first argument is the output. So rotate x function. So if you say AB comma alpha, so what happened here is A will be the result, okay, and then B, and then you just multiply B with rotation around x-axis by alpha. So that's the effect of rotate x function in mat4 in glMatrix library. Okay, so I'm going to be using this function here. So the second argument will be this matrix itself, band transform, and the amount of rotation is pi over 2. Okay, so now the band transform matrix is rotated by 90 degrees around the x-axis. If I refresh my screen, the ring is now upright. Okay, so before the ring was on the z-axis, but now the ring is upright. Okay, so now let's question about the first transformation on the ring. So now I'm going to add the crown. The crown is just a small torus, a smaller torus. So when I start with the crown, so I need to draw the crown inside my draw function, but of course I want to draw the crown, okay, and I want to be using the crown transform. So I want to replace that with crown transform, okay. So what I'm doing here is, remember the function, the draw function is given the incoming coordinate frame that can be used to transform the entire object, right? if I want to transform the entire ring, the coordinate frame matrix that is given to you can be used to pre-multiply the entire process here. Okay, so that's why I'm post-multiplying the crown matrix with the incoming coordinate frame, and the result will go to a temp matrix. And then I'm using the temp as the actual matrix to transform the second torus, which is the crown. Okay? So if I now do that, then you will see the output. Refresh, you will see the second ring, but the second ring is still on the z-axis, right? So I think we want to place the smaller ring at the top of my band. So what transformation do I have to apply to my smaller torus? Translate along z by how much?
Radius.
By the radius of the band,
Yeah,
right?
big radius.
Okay. That means I need to prepare another transformation. Okay. And then let's call it move up. Okay. I need to start with a vector. Vector from value 0, 0, comma, the bigger radius is about 1. Okay, maybe I can use 0.9. Let's try with 0.9. Okay, but from there I need to create a matrix. I cannot use a vector to transform. I need to create a matrix. Okay, so then my next step is to create another matrix that I can use to apply translation to the crown transform. Okay, so the next operation that I'm going to do here would be to where am I? Okay, I can apply translate. So math for translate. Okay, and then the output will go to crown transform. Okay, the first operand is crown transform, and then the translation amount would be move up. Okay, so that's how I apply translation along the z-axis to my crown transform matrix. So let's refresh, reload the object. So now that the crown is now at the top of the ring, okay, so now I can put the third object, which is the diamond, and let's use a cube for my diamond because I already prepared a cube here. Okay, so tell me what to do. Tell me what to write in order to add a cube to my object. This dot
diamond black stone.
gemstone gem. Okay, new cube, right? GL. So my cube constructor takes the size. What do you want to the size of the diamond, the cube?
I feel like it'd be about the same size as the crown.
15.
Yeah, 15.
Okay, and then how many subdivision? Let's say 3. Okay, and then use the default random color. Okay, and then I need to render, right? I need to render. Do I need to allocate another matrix for my gemstone? Yes or no?
Yeah.
Yes. Yes. Okay, I need to allocate another matrix for my diamond transformation, right? So let's call it gem transform. Okay, math for create. Okay, and then what transformation you want to apply to the cube?
Translate it and rotate it.
Okay, let's make it more interesting. Okay, let's say I want to make the corner of my cube to point up. How do I do that?
Rotate. Yeah, 2 rotations.
So this is the when I built my cube, the center of my cube is, the origin is the center of my cube, okay? So now the effect that I want to see is I want to make it one of the corners of the cube to point up. So now the question is, what will be the transformation that I have to apply?
Could you just rotate it like 45 degrees along X and then 90 along?
Okay, so if you rotate, so let's say the x-axis is this axis. Okay, let's say the axis is this axis. So if you rotate by how much?
Just like 45 degrees.
45 degrees.
Time to get it pointed.
So now the top edge will be
And then you
parallel
can
to the
just
ground, right?
Rotate it along the Y.
And then
90 or 45 degrees. 90 again.
what's next? You rotate again.
Yep.
But the question is rotate with respect to which axis?
Yeah. Lots.
So remember, whenever you do the rotation to the cube, right, the local coordinate rotates with you. Remember that. Okay? So now when you want to make that tip to be at the top, I don't think you want to rotate with respect to the green axis, because rotating around the green axis will give you this effect.
So
Probably what you want to do is you want to rotate with respect to the global axis, right? Are you with me? See the difference between rotating around the local axis versus around the global axis. Okay? Okay, so the other way of doing the transformation is you can rotate just a simple one rotation if I use the diagonal, this diagonal as my axis of rotation, okay? And then immediately it will take the cube. So if I use the diagonal as my axis of rotation, that will take this point to be at the top. That's another way of doing it, right? So I can do it in one shot. Okay? Instead of using two rotation, if I just use this diagonal axis, it will give me the final result in one transformation. Okay? So what I'm going to do, I'm going to use that axis. I'm going to use a diagonal and then rotate around the diagonal. Just a single transformation. Okay? So tell me what to do here. I need to put, yes,
Does
Tyler.
that diagonal line still go through the center of the cube? Like all the
We have to choose, so then the diagonal would go to the center of the cube.
Yeah, because wouldn't it not quite line up if it wasn't? You'd have to like rotate it, then slightly move it. If it were not in the center of the cube.
Yeah, so good question, because you may be building your cube using one of the corners as 0, 0, 0, right? Okay, because it depends how you build your cube, because one of you may be building like this is the 0, 0, or this is the 0, 0, 0, 0, right? So if you do that, then if you rotate around using the diagonal, then the visual effect will be something like this. Okay? While when I built my cube, the origin is at the center, so when I rotate around that diagonal, the visual effect will be like that. Yeah, so you need to know where the origin is when you build the object. Okay? So I'm going to be using the diagonal, okay? So then I have to build the rotation, and there's a function under the mat4 library from rotation, okay? So the function is called mat4 from rotation, okay? And then the from rotation takes 3 arguments. the first argument is the output, and then the second argument is the angle, the third argument is the axis. Okay, so now we need to calculate the right amount of angle. So if I do want to rotate along the diagonal, what would be the right angle? What would be the correct angle to bring that vertex to the top?
You have to go halfway between the edges.
Okay, so if I have a line here, right? So if I have a line, okay, so the diagonal, so then I need to know, can you see? So this is diagonal, right? And the angle that I want to rotate would be from the center to that vertex, right? So that angle. Are you with me? No? Okay, so imagine like this is the center line, okay, the diagonal, and this is the angle. So I'm trying to connect that vertex with my origin. Okay, is it 45?
Yeah.
Are you sure?
No, it's not.
The center, what is the height of that triangle? If the triangle is at -1 plus 1, so if the side of the triangle is 2, right? Plus 1 plus -1 all over, right? So the center is 0, 0, 0, right? What is the height? 1. The height is 1. What is the length of that diagonal?
Square root 2.
Square root of 2. You're right. So then what is the length of the diagonal? We have 1, we have square root of 2, so then square root of 3. Okay? So you need to come up with the right geometry, right? So we have a triangle here. Imagine you have a triangle, right? Okay? So the height of that side is 1, the length of the base is square root of 2, so then the hypotenuse is square root of 3. Okay? So then that angle would be this is 1, this is square root of 2, and this is square root of 3. So we want to rotate with respect to that angle. Okay? So that angle is, theta is, how do I get theta?
Depends on if you go to cosine or sine or tan.
I can use cosine, right? If I take 1 over square root of 3, that will be like inverse cosine of 1 square root over 3. Are you with me? Okay. So we need to calculate that angle. Okay. So let's calculate that angle. So that angle would be math a cos math 1 over math square root of 3. So that will be my angle. Okay? So once I have the angle, then I can create the matrix. So now the matrix would be, I need to move to the line after I create the gem transform. This gem transform. And then the next argument will be the angle. The angle is the previous line. And then the third argument will be the axis of rotation. And the axis of rotation will be just create, maybe I just use another local variable. Okay, axis rotation. So I can create a new vector from values. Okay, so tell me what will be the axis?
Would be 1, 1, 0.
Is diagonal, right? And the axis is parallel with the what plane? XY plane. Okay. because it's parallel with the xy plane. That means the z component is 0. Okay, the z component is 0, and it's like diagonal along the xy plane. So it will be 1, 1, 0. Question?
You have more semicolon.
What am I missing?
A semicolon.
In the front rotation line of this one.
Next line.
Is a function.
Okay. Then I'm going to put the axis of rotation at my third argument. Okay? So I have the gem transform matrix for my diamond, so I can now use that matrix to render my cube, my gem. Okay? So I'm going to be doing the same thing. Draw again, vertex array attribute, color attribute, model uniform, this TMP, but of course I need to do the matrix multiplication before I'm using TMP at line 31. So I'm going to say mul TMP coordinate frame this gem transform. Okay?
And if you
Does he need to be-
the coordinate frame, it says color attribute.
What am I missing?
Second parameter.
The second parameter is the color attribute, should be coordinate frame.
On the above, on the like.
Oh, thank you. Thank you. There we go. Okay, let's save and then refresh, reload. Where's the cube? Oh, it's in the middle. We didn't pull it up yet. But is it orienting correctly? Let's disable the bend and the crown so we can see it. Okay, let's. Is it pointing in the right direction?
Looks like it,
Yeah.
Okay. So then the next step is to pull it up, right? And we want to apply translation along which axis?
Z.
Which z?
The global.
The global z. You're right. We want to translate along the global z, not the local z, because if you translate along the local z, you'll be pulling the diamond away from the z-axis, right? So we want to pull it up along the global z. So tell me what to write next. So when I'm going to do the global transformation, what is the right order of my transform? Okay. So I have the gem transform. Right? So my question to you, I'm going to give you two options. Which one do I have to write in my code? Translate z multiply gem trans or TMP gem trans multiply trans z. The effect I want to see is to translate along the global z axis. Which one, A or B?
A.
How many of you say A? How many of you say B? How many of you don't know? Okay, remember, whatever you see in here, whatever you see to the right of that matrix will be done with respect to that matrix. Okay, so when you do B, the translation along z-axis will be done with respect to the z of your transform gem. Okay, but if you do the translation z on the left side, then the operation will be done with respect to the global coordinate. So the answer is A. The answer is A. Okay? So we had to create a translation but we have to multiply it on the left-hand side, not on the right-hand side. Okay? Question about the difference between the two operations? So then after I have the gem transform rotated by that amount, so the next step is for me to multiply again. Okay? So I already have the move up vector, but what I need to do is I just need to create another matrix for my translation. Okay, so I can just call another. Let's call it move it up now instead of move up. Okay, but I'm going to create a mat4 object from translation. Okay. And from translation takes two arguments. The first argument would be the matrix that I want to operate. In this case, I'm creating a new one. Okay, so I'm creating a new one. So I'm going to create a new one. And then the second argument will be the vector. I can just move up from line 12. Okay, so move it up is now a matrix that I can pre-multiply with gem to get the result. Okay, so let me use mat4 multiply. So multiply takes three arguments. So the first argument will be the product. The product will go to gem transform. Okay, the second argument will be whatever you put in here. So in our case, the second argument will be move it up. And then the third argument is whatever you put in here, which is this gem transform. Question about how to use mat4 multiply to implement a. Let me put it as a comment here. So the effect is gem transform is move it up multiplied by gem transform. Okay, let's confirm the output. Refresh. Yes, it is at the top of the z-axis. Okay, so now I can re-render the other two objects, the band and the crown. And then now you can get a ring. Question? Does it make sense? Okay, let me close my recording and I'm going to upload the recording to Blackboard.